Based on the provided context, it is not possible to definitively classify the hazard level without additional information. However, based on the mention of a tank, the following considerations may apply. If the tank contains flammable liquids or gases, they may create a hazardous vapor atmosphere. If the tank contains electrical equipment or components, they may pose an electrical hazard if not properly sealed or protected. Whether the interior of the tank is considered a hazardous location depends on the presence of hazardous substances and whether they create an ignitable atmosphere. The following factors should be considered. Firstly, concentration. The concentration of flammable vapors or gases should be assessed to determine if it exceeds the lower explosive limit, or LEL. Secondly, ventilation. The tank's ventilation system needs to be evaluated to ensure adequate air exchange and prevent the accumulation of hazardous vapors. Thirdly, ignition sources. The presence of ignition sources, such as sparks, flames, or electrical equipment, within the tank must be identified. To determine the specific hazard level and whether the interior of the tank is considered a hazardous location, the following information is typically required: type of substance stored in the tank, concentration of flammable vapors or gases, ventilation system specifications, electrical equipment present and its protection, and presence of ignition sources. Without more detailed information about the specific conditions inside the tank, it is not possible to provide a definitive classification. However, based on the potential presence of flammable substances and electrical hazards, it is recommended to perform a thorough hazard assessment and follow appropriate safety precautions as necessary. A hazard assessment for a tank containing potentially flammable substances or electrical equipment involves the systematic evaluation of potential dangers and the implementation of appropriate safety measures. Firstly, identify the substances stored in the tank. Determine the chemical properties of the stored materials, paying close attention to their flammability, volatility, and potential to release hazardous vapors. Consult safety data sheets or SDS for detailed information on the substances. Secondly, evaluate the potential for vapor release. Assess the tank's design and operating conditions to determine the likelihood of vapor release. Consider factors such as temperature, pressure, and the presence of any leaks or openings. Thirdly, assess the ventilation system. Evaluate the effectiveness of the tank's ventilation system in removing hazardous vapors. Ensure that the system is properly designed, maintained, and operated to provide adequate air exchange. Fourthly, determine the concentration of flammable vapors. Use appropriate monitoring equipment to measure the concentration of flammable vapors inside the tank. Compare the measured values to the lower explosive limit, or LEL, of the substance to determine if an explosive atmosphere exists. The lower explosive limit, or LEL, is the lowest concentration of a gas or vapor in air that is capable of igniting in the presence of an ignition source. It is expressed as a percentage by volume of the gas or vapor in air. If the concentration of flammable vapors exceeds the LEL, an explosive atmosphere is present, and precautions must be taken to prevent ignition. Fifthly, identify potential ignition sources. Identify any potential ignition sources inside or near the tank, such as electrical equipment, open flames, static electricity, or hot surfaces. Ensure that all electrical equipment is properly grounded and that any potential sources of static electricity are eliminated. Sixthly, classify the hazardous location. Based on the evaluation of flammable vapor concentrations and potential ignition sources, classify the area inside and around the tank according to the applicable hazardous location standards. This classification will determine the types of equipment and procedures that are required to ensure safety. Hazardous locations are classified into different zones or divisions based on the likelihood of a flammable or explosive atmosphere being present. These classifications are used to determine the appropriate types of equipment and wiring methods to use in the area. The National Electrical Code, or NEC, Article 500 provides detailed information on hazardous location classifications. Seventhly, implement control measures. Implement appropriate control measures to reduce the risk of fire or explosion. These measures may include using intrinsically safe equipment, providing explosion-proof enclosures, implementing strict procedures for hot work, and providing fire suppression systems. Intrinsically safe equipment is designed to prevent the release of sufficient energy to ignite a flammable atmosphere. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Hot-wet procedures involve controlling the use of open flames or other sources of ignition in hazardous areas. Fire suppression systems are designed to automatically detect and suppress fires. 8th, provide training. Provide comprehensive training to all personnel who work on or near the tank. This training should cover the hazards of flammable materials, the proper use of safety equipment, and the procedures for responding to emergencies. 9th, develop an emergency response plan. Develop a detailed emergency response plan that outlines the steps to be taken in the event of a fire, explosion, or other emergency. This plan should include procedures for evacuation, notification of emergency services, and the use of fire suppression equipment. 10th, conduct regular inspections. Conduct regular inspections of the tank, ventilation system, and safety equipment to ensure that they are in good working order. Document the results of these inspections and take corrective action to address any deficiencies. 11th, review and update the hazard assessment. Review and update the hazard assessment periodically to reflect changes in the tank's operating conditions, the substances stored, or the applicable safety standards. The following are some additional considerations for hazard assessments involving tanks. Firstly, consider the age and condition of the tank. Older tanks may be more susceptible to leaks or other failures. Secondly, consider the potential for corrosion. Corrosion can weaken the tank's structure and increase the risk of leaks. Thirdly, consider the potential for overpressure. Overpressure can cause the tank to rupture, releasing flammable materials into the atmosphere. Fourthly, consider the potential for static electricity. Static electricity can build up on the surface of the tank and discharge, causing an ignition. Fifthly, consider the potential for lightning strikes. Lightning strikes can ignite flammable vapors inside the tank. Sixthly, consider the potential for human error. Human error is a major cause of accidents in industrial settings. Ensure that personnel are properly trained and that procedures are followed carefully. By following these steps and considering the additional factors, a thorough hazard assessment can be performed to ensure the safe operation of tanks containing flammable substances or electrical equipment. Now let's talk about specific hazardous location classifications. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those that are hazardous because of the presence of combustible dust. Class 3 locations are those that are hazardous because of the presence of easily ignitable fibers or flyings, but in quantities sufficient to produce ignitable mixtures. Within each class, there are divisions that further define the likelihood of the hazard being present. Division 1 locations are those in which the hazard is present under normal operating conditions. Division 2 locations are those in which the hazard is present only under abnormal conditions, such as a spill or leak. In addition to classes and divisions, hazardous locations are also grouped by the type of explosive atmosphere that may be present. These groups are based on the ignition temperature and explosion pressure of the materials involved. Group atmospheres contain acetylene. Group B atmospheres contain hydrogen, or gases or vapors of equivalent hazard such as manufactured gas. Group C atmospheres contain ethyl, ether, ethylene, or gases or vapors of equivalent hazard. Group D atmospheres contain acetone, ammonia, benzene, butane, ethanol, gasoline, hexane, methane, methanol, naphtha, propane, or gases or vapors of equivalent hazard. Group E atmospheres contain combustible metal dust including aluminum, magnesium, and their alloys. Group F atmospheres contain carbon black, coal dust, or coke dust. Group G atmospheres contain flour, starch, or grain dusts. Equipment used in hazardous locations must be designed and tested to ensure that it will not cause an ignition. This equipment is typically marked with the class, division, and group for which it is approved. For example, equipment marked Class 1, Division 1, Group D is suitable for use in locations where flammable gases or vapors such as propane are present under normal operating conditions. Now let's talk about specific safety precautions that should be taken around tanks containing flammable liquids or gases. Firstly, ensure proper ventilation. Provide adequate ventilation to prevent the accumulation of flammable vapors. This may involve natural ventilation, such as open doors and windows, or mechanical ventilation, such as fans and blowers. Secondly, eliminate ignition sources. Eliminate any potential ignition sources in the vicinity of the tank, such as open flames, sparks, or hot surfaces. Use non-sparking tools and equipment. Thirdly, control static electricity. Take steps to control static electricity, which can be a source of ignition. Ground all equipment and use static dissipative materials. Fourthly, prevent overfilling. Prevent overfilling the tank, which can lead to spills and releases of flammable liquids or gases. Use level indicators and alarms to monitor the liquid level in the tank. Fifthly, provide spill containment. Provide spill containment measures to prevent spills from spreading. This may involve dikes, berms, or other barriers. Sixthly, use personal protective equipment, or PPE. Use appropriate personal protective equipment such as respirators, gloves, and eye protection when working around flammable liquids or gases. Seventhly, follow safe work procedures. Follow safe work procedures for all tasks performed around the tank. This may include procedures for opening and closing the tank, transferring liquids or gases, and performing maintenance. Eighthly, train personnel. Train all personnel who work around the tank on the hazards of flammable liquids or gases and the safety precautions that must be taken. Ninthly, inspect regularly. Inspect the tank and associated equipment regularly to identify any potential problems. Correct any deficiencies promptly. Tenthly, have an emergency plan. Have an emergency plan in place in case of a fire, explosion, or other incident. This plan should include procedures for evacuation, notification of emergency services, and the use of fire suppression equipment. In addition to these general safety precautions, there may be specific requirements depending on the type of flammable liquid or gas being stored and the location of the tank. Consult applicable codes and standards for detailed requirements. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to the storage and handling of flammable liquids and gases. These standards include NFPA 30, Flammable and Combustible Liquids Code, and NFPA 58, Liquefied Petroleum Gas Code. The Occupational Safety and Health Administration, or OSHA, also has regulations related to the storage and handling of flammable liquids and gases. These regulations can be found in Title 29 of the Code of Federal Regulations, or CFR, Part 1910.106 for flammable and combustible liquids and Part 1910.110 for storage and handling of liquefied petroleum gases. By following these safety precautions and consulting applicable codes and standards, the risks associated with tanks containing flammable liquids or gases can be minimized. The presence of electrical equipment within a tank containing potentially flammable substances introduces additional safety considerations. Firstly, use appropriately rated equipment. Ensure that all electrical equipment used inside or near the tank is rated for the specific hazardous location classification. This means that the equipment must be designed and tested to prevent ignition of flammable vapors or dusts. Secondly, use explosion-proof enclosures. Use explosion-proof enclosures for electrical equipment that is located in a Class 1, Division 1 or Division 2 hazardous location. These enclosures are designed to contain any internal explosion and prevent it from propagating to the surrounding atmosphere. Thirdly, use intrinsically safe circuits. Use intrinsically safe circuits for instrumentation and control systems. Intrinsically safe circuits are designed to limit the amount of energy available to ignite a flammable atmosphere. Fourthly, ground all equipment. Ground all electrical equipment to prevent the buildup of static electricity, which can be a source of ignition. Fifthly, use proper wiring methods. Use proper wiring methods, such as conduit and sealing fittings, to prevent the entry of flammable vapors or dust into electrical enclosures. Sixthly, inspect regularly. Inspect all electrical equipment regularly to ensure that it is in good working order and that there are no signs of damage or deterioration. Seventhly, train personnel. Train all personnel who work on or near electrical equipment in hazardous locations on the specific hazards and safety precautions. Eighthly, obtain proper permits. Obtain proper permits before performing any electrical work in a hazardous location. Ninthly, follow lockout/tagout procedures. Follow lockout/tagout procedures to ensure that electrical equipment is de-energized before any maintenance or repair work is performed. Tenthly, use qualified personnel. Use only qualified and experienced personnel to perform electrical work in hazardous locations. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations. Article 500 of the NEC covers the general requirements for hazardous locations, while Articles 501 through 506 cover the specific requirements for different types of hazardous locations. In addition to the NEC, other codes and standards may also apply, depending on the specific application and location. These may include standards from the National Fire Protection Association, or NFPA, and the Occupational Safety and Health Administration, or OSHA. When selecting electrical equipment for use in a hazardous location, it is important to consider the following factors. Firstly, the class, division, and group of the hazardous location. Secondly, the temperature rating of the equipment. Thirdly, the area classification. Fourthly, the manufacturer's specifications. It is also important to ensure that the equipment is properly installed and maintained in accordance with the manufacturer's instructions and applicable codes and standards. The specific requirements for electrical installations in hazardous locations can be complex and may vary depending on the specific application. It is important to consult with qualified professionals to ensure that all applicable requirements are met. Furthermore, regarding ventilation systems, a well-designed and maintained ventilation system is crucial for preventing the accumulation of flammable vapors within a tank. Firstly, ensure adequate air exchange. The ventilation system should provide an adequate rate of air exchange to remove any flammable vapors that may be released from the stored substance. Secondly, design for vapor density. The ventilation system should be designed to account for the density of the vapors being removed. If the vapors are heavier than air, the ventilation system should draw air from the bottom of the tank. If the vapors are lighter than air, the ventilation system should draw air from the top of the tank. Thirdly, use appropriate fans. Use explosion-proof fans and motors in the ventilation system to prevent ignition of flammable vapors. Fourthly, locate intakes and exhausts properly. Locate the ventilation system's intakes and exhausts in areas where they will not draw in or discharge flammable vapors. Fifthly, inspect regularly. Inspect the ventilation system regularly to ensure that it is operating properly. Check for any signs of damage or deterioration. Sixthly, maintain records. Maintain records of all inspections and maintenance performed on the ventilation system. Seventhly, monitor vapor concentrations. Monitor the concentration of flammable vapors in the tank to ensure that the ventilation system is effectively removing them. Eighthly, consider natural ventilation. In some cases, natural ventilation may be sufficient to remove flammable vapors. However, natural ventilation should only be used if it can be demonstrated that it will provide adequate air exchange. Ninthly, use alarms. Use alarms to warn personnel if the concentration of flammable vapors exceeds a safe level. Tenthly, train personnel. Train personnel on the proper operation and maintenance of the ventilation system. The design and operation of ventilation systems for hazardous locations are governed by a number of codes and standards, including the National Fire Protection Association, or NFPA 91, standard for exhaust systems for air conveying of vapors, gases, mists, and non-combustible particulate solids, and the American Conference of Governmental Industrial Hygienists, ORIC-J, Industrial Ventilation, a Manual of Recommended Practice. These codes and standards provide detailed guidance on the design, installation, and maintenance of ventilation systems for hazardous locations. The effectiveness of a ventilation system depends on a number of factors, including the size and shape of the tank, the type of substance being stored, the temperature and pressure inside the tank, and the location of the ventilation system's intakes and exhausts. It is important to carefully consider these factors when designing and installing a ventilation system for a hazardous location. Continuous monitoring of vapor concentrations within the tank is essential for ensuring the effectiveness of the ventilation system and the safety of the surrounding area. Vapor monitoring can be performed using a variety of methods, including firstly, portable gas detectors. Portable gas detectors are handheld devices that can be used to measure the concentration of flammable vapors in the air. Secondly, fixed gas detectors. Fixed gas detectors are permanently installed devices that continuously monitor the concentration of flammable vapors in the air. Thirdly, gas chromatography. Gas chromatography is a laboratory technique that can be used to identify and quantify the different types of vapors present in the air. The choice of vapor monitoring method will depend on the specific application and the level of accuracy required. Portable gas detectors are suitable for spot checks and for monitoring vapor concentrations in confined spaces. Fixed gas detectors are suitable for continuous monitoring of vapor concentrations in areas where there is a high risk of flammable vapor release. Gas chromatography is suitable for identifying and quantifying the different types of vapors present in the air, but it is not suitable for continuous monitoring. The readings from vapor monitoring equipment should be regularly recorded and reviewed to ensure that the ventilation system is operating effectively and that vapor concentrations are within safe limits. If vapor concentrations exceed safe limits, immediate action should be taken to identify and correct the problem. This may involve increasing the ventilation rate, repairing leaks, or shutting down the process. Personnel should be trained on the proper use of vapor monitoring equipment and on the procedures to follow if vapor concentrations exceed safe limits. Remember, safety is paramount when working with flammable substances and electrical equipment in hazardous locations. A thorough understanding of the potential hazards, the applicable codes and standards, and the proper safety precautions is essential for preventing accidents and ensuring the safety of personnel and the environment.